Hello everyone, welcome back to my AP Physics 1 review video, and this is Unit 2. We're having two videos for this unit. This one's for concept only, and the next video is for questions only. And so let's start by systems. Systems is a collection of objects and can treat it as one object, and its mass is the sum of all the object's mass. The system is capable of transferring mass and energy. Individual objects may behave differently than others in the entire system. The internal structure of the system affects the analysis of the system. As the variables external to the system are changed, the system substructure may change. But don't worry about it too much. Just understand that these are true. There's probably not a lot of questions will be tested on these concepts. And next is center mass. For a uniformly density system that has center mass at the center of the system, and if we treat individual objects as particles, then the center mass can be represented by these two equations here, which is the sum of the mass 1 times the position 1 plus mass 2 times position 2, and all over the mass 1 plus mass 2, dot, dot, dot. So you are taking the sum of all these to get the center mass. And the next one is force. A force is a push or pull that interact between two objects or two systems. One object cannot exert a force. It must be interaction between two objects. And force is a vector and can be written as F and with a vector symbol above. There are two types of forces, which are contact force, and they must be caused by contacting another objects. And there's a field force, which can be experienced without contacting. And the two examples will be gravitational or electrical fields. And so here are the three contact forces. Got the normal force. Normal means perpendicular to, so which means that the normal force always acts perpendicular to the surface, even the surface is on an incline like this. The normal force will go up to the left, and it must be perpendicular to the surface. The friction force is always parallel to the surface. It's opposed motion. So in this incline problem, the force of friction is parallel to the surface. And the tension force caused by a rope or string, which can be denoted by F sub t. And the field force we will talk about in AP Physics 1 is force of gravity, or you can write it as weight, which force Fg or W, both are vectors, and they are going to the center mass of the other object. I will recommend you to write F sub G instead of W, since W may confuse with the other quantities such as work. And the next concept is free body diagram. It's a diagram that shows all the forces acting on the objects. The dots are starting at the center mass, and usually give you a point and let you to draw the force. And draw the origin of force only, not the components. And the magnitude of the force and the direction matters. So if the force pointing to the right, then you have to draw like this. And the magnitude matters, which means that this is force 1 and this is force 2, which means that the magnitude of force 1 is greater than magnitude of force 2. And the example is an object on an incline, which is here. The force of gravity, there's always a force of gravity acting on the object. And the normal force, you can see it's perpendicular to the surface. force of friction right here is parallel to the surface, and the dot is starting above the incline because it's at the center of mass. Next one is Newton's third law. It says that FAB is negative FBA, which means that a force A on B is the equal magnitude to B to A, B on A, but opposite direction. This negative with the vector symbol means the opposite direction. And the Newton's third law of force pair always involved with two objects, which means that the force must be the interaction of two objects. If the equation only have one object, then it's not a Newton's third law of force pair. Here's an example. A person sitting on a chair provide a normal force downward on the chair, while the chair provide an upward normal force on the person. They're the same force, the normal force, and acting on two objects. There's a person and the chair. That force can be written as the sigma symbol, which is the summation symbol, F with a vector symbol. An object in translational equilibrium such that the net force equal to 0, which means that it's either not moving or moving at constant velocity. And static equilibrium means the velocity is equal to 0. It's not moving at all. Newton's first law. All objects will stay at rest or moving at constant velocity in a straight line only, unless acted by an external force that result in an imbalance forces and the net force is not equal to 0. This only applies in inertial reference frame, means that the acceleration is equal to 0 in that reference frame. Note that it says constant velocity on a straight line. If it's not a straight line, which means the object changes its direction, it also changes its velocity and acceleration, which means that there's a net force on it. This is because acceleration and velocity are vector quantity. Newton's second law, F equal to ma, and you can solve for A is equal to the net force divided by its mass of the system. This is on the equation sheet. This acceleration is on the equation sheet. The SI unit is Newton. So if you go back to this net force equation, the unit is kilogram times meter over second square. This is equal to Newton. It can be separated into components. For example, acceleration in the x direction is equal to the sum of the forces in the x direction by its mass. It's applied for all directions. It's applied for x direction, y direction, and z direction. Gravitational force. The magnitude of gravitational force equal to big G m1 m2 over r squared. The big G is the gravitational constant, which is 6.67048 times 10 to the negative 11 Newton meter over kilogram squared. And this is on the equation sheet, so you don't have to memorize it. R is the distance between the center of mass. It's not the radius. R sometimes can be confused with radius, but it's the distance between center of mass. It always points to the center mass of the other object. Recall that acceleration in the y direction equal to negative g, then the magnitude of the gravitational force is m1g. The magnitude ignores the direction, so the g is equal to big G times m2, which is the mass of the planet, and where m1 is current object and m2 is the other object. Usually m2 is the planet. Fg is also the weight, and g is approximately equal to 10 meter per second squared, which you can use it on AP exam. Or there's a special unit Newton over kilogram. It's the gravitational field strength is from the net force over kilogram equation, where the net force is Newton, the mass is kilogram. And they are mathematically equivalent, so you can use either of these. The parent weight is the mass times the gravity acceleration plus the acceleration in the y direction. Assume that up is positive. The scale measures the normal force acting on the scale. The parent weightless is when the Fg is the only force acting on the object. The mass of the gravity is gravitational mass, which is the equation above. This equation here, these masses are gravitational mass, while the Newton's second law, F equal to ma, is inertial mass, but they're mathematically equivalent, and it's proof using experiments that they're equivalent. So you can use either of these, and you can just switch the m. Friction force. Friction is from the roughness of a surface, where the surface are not perfectly flat. So a surface might look something like this. And when the object trying to go through this, it have to pass the bump here. And it takes force to break this bump here. So there is a friction force. The notation is F sub F. The magnitude does not depend on the area of the contact between the object and the surface. The kinetic friction, which is the magnitude of kinetic friction, equal to the mu k times Fn. Mu k is the friction coefficient between the surface, and when kinetic friction occurs, it's when the surface is contacting and sliding relative to another surface. It must be sliding. Mu is the dimensionless scalar, the friction coefficient. It's only dependent on the material of the two surfaces. And the direction of kinetic friction is the opposite to the direction of velocity. It's independent to the force applied, but it's dependent on the velocity vector. The static friction, which is the magnitude of static friction, is less than equal to mu s times Fn. It occurs when the surface is all contacting but not sliding. It can happen when the object is not moving, or the wheels are rolling without slipping to the surface. The wheel, it changed the surface of contact, so it's actually never slide relative to the surface, and it's the static friction. The maximum static friction is mu s times Fn. The maximum static friction is always greater than kinetic friction in any two surfaces, so we can say that mu s is greater than mu k. It prevents the potential movement, but it also helps with motion. For example, a person walking, the forward force is the static friction on the ground on the person, which prevents the feet from going backward. In UCM, we'll cover in this video, which the static friction acts as the centripetal force, and it prevents it from moving tangent from its path, so it can continue move pointing to the center of the circle and move in a circular motion. Spring force. For an ideal string that the mass of the spring is negligible, the force is equal to negative kx. The negative means that the force of spring is opposite to the displacement from equilibrium. The k is the spring constant in Newton over a meter, which is the stiffness of the spring. Delta x is the displacement of the spring from its equilibrium position. The negative sign means the direction of spring force is opposite to the displacement, which the force is always pointing to the equilibrium position. Circular motion is when the object moves in a circular path. Since changing direction will change the acceleration because the acceleration is a vector quantity, there must be a centripetal acceleration. Centripetal means center seeking toward the center of the circle. Centripetal force is affected by the net force. It's always the net force. Centripetal force is not a force and it should not be on the free body diagram unless it's specifically mentioned to draw the centripetal force. Uniform circular motion is when the tangential speed is constant. Speed. The equation for centripetal acceleration is vt squared over r. Vt is the tangential speed, it's not velocity. R is the radius of the circular path. And since you got F equal to ma, the centripetal force must be mass times the centripetal acceleration, which is mvt squared over r. In UCM, velocity is equal to distance over time, which the velocity of the circular path is 2 pi r over t. 2 pi r represents the circumference of the circle, and t is the period where it takes for one full revolution. We can substitute v in back to AC. We get 4 pi squared r over t squared, where we can say that the force of centripetal force is 4 pi squared mr over t squared. And here's another concept. T is equal to 1 over f. F is the frequency. So the frequency and period are always inverse to each other. In a circular road or merry-go-round problem, the centripetal force is the force of static friction. We can set force of static friction equal to force of centripetal to solve the problem. In bend curve problem, when theta is defined as the angle of the road to the curve, the angle between the normal force to the vertical, then you can say that force of normal times sine theta is equal to the centripetal force. And Fn cosine theta is equal to Fg. So the centripetal acceleration equal to g tangent theta. The y component of the normal force is always equal to the gravitational force. In the x-axis, which is the inward to the circle, is always the centripetal force. In a conical pendulum problem, which will look something like this, an object hanging and it's swinging around like a circle. When it's in UCM, the centripetal force is by the component of the tension force. So if we have a theta here, then the centripetal force will be Ft sine theta. And the velocity, you can derive it, which is square root Rg tangent theta. When the object is connected to a string and swung in a vertical circle, which means that it's swung like this. Let me draw a better circle. Swung like this. At the top here, you can draw the free body diagram. You got a force of tension and force of gravity. Make sure that if they're in the same direction, draw them with some space in between. Even they're opposite direction to each other, make sure there's some space in between to better distinguish between which force are there. And the minimum speed is v equal to square root gr. And the next one is Kepler's law. Kepler's first and second law is not tested, but here's a context for Kepler's third law, which is mentioned in the course exam description. So a satellite, which could be Earth, is orbiting a primary, which is Sun. The satellite must be orbiting in elliptical orbit. That the primary must be one of the two foci, which is the plural focus, on the major axis, a line that connecting the farthest point on the ellipse. The semi-major axis is the line of a vertex connecting to the center, while the semi-minor axis is the perpendicular to semi-major axis, which is the co-vertex connected to the center. So what do you mean? So here is a image of a ellipse. The points connecting, the line connecting the vertex, this is the major axis. The point connecting the two co-vertexes is is the minor axis. And when the vertex is connecting to the center, it's a semi-major axis. And when the co-vertex is connecting to the center, it's semi-minor axis. Eccentricity measures how far are the two foci, where 0 means they are coincide, it's completely a circle, or 1 means it's two parallel lines, or just a straight line. Kepler's second law, over a constant time interval, the area of the satellite sweep must be the same no matter its position. The area starts at its primary, so it's right here. And connecting the two positions of the satellite, which is right here, which connected by line of the path. So it will look like this. The area of this, area A, must be equal to the area of this. So which means that when the satellite is closer to the primary, its velocity will increase to have the same area when it's further apart. And Kepler's third law, which is t squared is proportional to r cubed. This symbol means proportional, which t squared is equal to 4 pi squared over GMP r cubed. T is the period of the orbit, which is how long it takes for the full revolution. R is the length of the semi-major axis, or the radius, if the path is completely circular, and G is the gravitational constant. MP is the mass of the primary. And that concludes my video for AP Physics 1 Unit 2. And please like and subscribe my video. And if you want, you can watch my question videos to get more detail on this concept. And I will see you next time.